cloud. Here we go. Okay, cool. Okay. So okay, this might get complicated pretty fast, but that's okay. Ask a lot of questions. There's not a ton of people here, so ask a lot of questions. The slide deck has some things written out a little bit better, yeah, just ask me when you're confused, and that'll be good. Okay, so welcome to part 2, technically, of the software workshop. This is a collaboration between the Sustainable Buildings Network, of which I am the chair, and Future Living Labs, which is Selena here, one of the co-presidents. This is a 2-part, well, I guess sort of a 4-part workshop. The first 2 parts were basic AutoCAD and basic Rhino. And so this second part is advanced AutoCAD and advanced Rhino. Unfortunately, the other co-president of Future Living Labs couldn't join us today, so they're going to record their section and post that, and so we'll get that sent out to everybody who registered, and so we can see that. So for today, we're going to be covering advanced AutoCAD. And so what that includes is talking about AutoLisp, which is what the programming language you can use to automate AutoCAD and interact with it programmatically. And I find it very cool, and you can do a lot of really powerful things, and it's very, very neat. So let's get going. Okay, there's a bit of an agenda. I'll skip through that. We don't need to go through that. Okay, so AutoLisp is based on the programming language called Lisp. I forgot to look up what it stands for. I don't actually remember, but you can Google it. It's one of the oldest programming languages there is. It's from 1958. It's 1 year younger than Fortran, which is pretty much the oldest high-level programming language. And it's probably the weirdest programming syntax you're ever likely to interact with. You can see a sample there on the right. The trick with Lisp is that everything is surrounded in parentheses, and it's all written a little bit backwards. So we'll get to that in a second. The other trick of Lisp, and which is going to be useful if you Google this stuff in the future, is that there's multiple versions. There's Common Lisp, there's Scheme, which is based on Lisp, there's Emacs Lisp, and then there's what we're using today, which is AutoLisp, also called Visual Lisp. The trick is that they're actually called different dialects because they're all very slightly different, and they use there's small differences in syntax, and so you have to append which version of Lisp you're looking for whenever you Google anything when you're looking this stuff up. So just a warning, they're all called different things. So this is what Lisp looks like, and Lisp is weird. Normally in C, Python, any sort of programming language that you'd be used to, you'd write x equals 3, but not in Lisp. In Lisp, you write set x as 3. You can see on the right here. Specifically in AutoLisp, you write set q x 3 for whatever reason. Just so we're clear, like the goal of this workshop is not to teach you Lisp or to teach you how to write AutoLisp. My goal is to give you the very, very basics, just enough to write a little tiny little script and do something cool in AutoCAD. And so I'm going to go through just the very basic overviews. In the presentation in the slide deck, there are some really good resources that I found that really helped me learn Lisp, and basically I got all my Lisp knowledge from there. So if you're really curious, I recommend actually reading through the proper tutorials there rather than this very abridged version. But we should be able to do some pretty cool stuff with what I show you today. So back to Lisp syntax. So normally x equals 3, Lisp set q x as 3. Normally you would write x equals 2 plus 3, but in Lisp you don't. You write it backwards. You write set x as plus 2, 3. So you have the operator first and then the arguments. It's all backwards. So that's the same thing with comparisons. So x greater than 3, but in Lisp you write greater than x 3. This gets pretty confusing when you're thinking about division or subtraction. You have to remember, okay, which order do they actually go in? So it gets a little tricky to remember. You just swap the operator out to the beginning, and then everything works basically the same. I think technically it's called prefix notation as opposed to infix notation, but I might be wrong with that, so don't quote me on that. Okay, so we're going to go through some really quick Lisp basics, and yeah, stop me if you're confused. So loops in Lisp actually do look pretty normal. There's a few that I find particularly useful. The while loop, it looks very normal. Everything is surrounded by parentheses, so remember. So the while loop starts with an open parentheses and ends with a closed parentheses down here. You write while, and then this statement is whatever you're evaluating. So greater or x greater than 3, or as you write in Lisp, greater than x3 or whatever. And then all the statements that actually do stuff go in here. Unlike Python, Lisp does not care about indentation at all. It just makes it way easier to read if you indent things a little bit and put things on separate lines. But you could write this whole statement on one line. Lisp wouldn't care. Another thing I find useful, there's no for loop in Lisp, but there is a for each. And so for each, and then some variable and in list. And so for every iteration of this loop, it'll assign variation to another item in Lisp. And you can use, or every iteration of this loop, it'll assign this variable rather to the next item in Lisp. And you can do in list, and you can do stuff using that variable in the statements in here, and then it'll run again, assign the variable to the next item in the list, and then you can do some more stuff. And the last one is repeat. You just repeat, and then the number of times you want to repeat something, and then you can do stuff a certain number of times within that loop. Fairly straightforward. Okay. Where it starts to get a little bit more complicated when we start talking about logic in Lisp rather. So let's start with the if statement. It looks fairly normal. So you write if, so open the parentheses there and close them down here, if, and then the statement that gets evaluated. And if this statement is true, it runs the first statement. If it's not true, it'll run the second. Now, the trick with that is that if you want to run multiple things, you can't. It'll only run this first one if it's true and the second one if it's false. So what you have to do is use this prog n command to run multiple statements. It does something fancy. I'm sure you can use it with fancy things. All you have to know for now is just that you can surround all the statements you want it to do with prog n, and then you can have the if statement do multiple things. So if, and then it'll do something here and then do something else if it's true. So it's running that first section. And then if it's false, it'll just run this false statement. If you wanted to evaluate multiple conditions, there is if and else. You can use those normally, but you could also use cond, standing for condition probably, where it'll evaluate statement 1, and then it'll do something if statement 1 is true. And then if that's false, it'll evaluate statement 2, and then do something if statement 2 is true, statement 3 is true, and you can add this. So in Lisp, t is true, just under lowercase t. It just is the, in Python, that would be, I think the keyword is just true, but in Lisp, it's just t. So if none of these are true, it'll always default to this at the end. Making sense so far? It's pretty straightforward, looks pretty normal. Everything's a little bit backwards, but okay, cool. Okay, so now we get to the fun part of Lisp. The cool thing about, so what Lisp is kind of built to do is work with lists, which is hard to say, but it's built to work with lists and work with them really well. So kind of key to Lisp, and in fact, key to working with AutoCAD in Lisp, is the concept of linked lists. So you can declare, or you can create a list in Lisp with a statement like this. You can write list, and then in this list, it's gonna be 1, 2, 3, and then it'll output a list 1, 2, 3. Fine. But what does that list actually mean? Well, lists in Lisp are built up of these things called cons cells. You can create a cons cell with the command cons and then 1, 2, and Lisp represents that as 1.2. But what that looks like is you can think of it as two little boxes connected together with a 1 in the first one. Oh, there's my cursor. There you go. A 1 in the first one and a 2 in the second one. And so that's a cons cell. But in a list, it's a bunch of cons cells linked together. So in the list 1, 2, 3, what it actually means is 3 cons cells. The first cons cell has 1 in the first box, and then the second box is actually a reference to the second cons cell. So the first item is 1, second item points to the second one, and then the second one, the first item is 2, and then the second part points to the third item, and then in the third one, the first item is 3, and then the second little box points to nil. So nil is just a nothing, it's empty value. And so all lists in Lisp it's called a linked list because all the elements are like linked together, and it terminates in nil. This will become more important later, but it's kind of neat. That means what you can do is build a list. So this list 1, 2, 3 is the same as saying cons 1, and the second item of the cons cell is cons 2, with the second item being cons 3, with the second item being nil. And then you close all those parentheses, and then it'll actually output a normal list 1, 2, 3, just the same as writing this, except it just took way more characters. So this will come back in a second, but you can obviously, I mean, maybe not obviously, but you can have nested lists as well. You can nest cons cells inside lists. You can, Lisp is, I don't think it might be a functional programming language. You can, just like Python, it's mildly functional, so you can have functions inside lists. In fact, when you write something like +2, 3, that's actually is a list that gets evaluated. And so you can do some really cool stuff with that. Not relevant, gets very complicated and really confusing to look at really quickly, so don't worry about it. But you can see the representation in terms of like cons cells of this nested list is this, where the first item is this list. The first item is, sorry, the first cons cell is actually this list, points to the beginning of this list, and then there, points there, points there. Yeah. This tree looks a little confusing. Don't really worry about it yet. So just think about this, where the first cell actually points to the rest of the list. So we're going to actually hop over to AutoCAD now and start looking at some code. And actually playing around with this stuff a little bit. So I'm looking at the slides myself down here, and so I recommend pulling them up, and you can follow along a little bit if you have them. Okay, so here's AutoCAD. This looks fairly normal, just AutoCAD. And so where all the Lisp is hiding is actually, you can type VLIDE or Visual Lisp Integrated Development Environment, press return, and here we go. This is where you can code Lisp in AutoCAD. It looks a little bit probably like the macro editor in Microsoft Excel or any of Microsoft Office products or whatever, but here's where it's all hiding. Okay, so one thing to note, this title bar will probably look different for you than it does for me. Every time you launch AutoCAD, this title bar chooses a random color, and it just is that color. And then when you close AutoCAD down and reopen it, it'll choose a different random color. I've spent ages Googling this and trying to figure out what's going on. It just does this, and so it's just a little broken. That's fine. Okay, but Lisp, just like Python, you can write commands in the console. So like we were talking about before, we can do list 1, 2, 3, blammo, there's a list. Or we could do set q x as 5, close parentheses, and then there. And now if you say x, there, has the value of 5. Fantastic. Set q x as maybe +2, 3. And then, well, x is still 5. Fantastic. Okay, so let's play around with these lists a little bit. So there's a couple commands that are very useful for playing around with these lists, and that is car and cdr. Okay, so let's take our list. We have let's set variable a as our list, 1, 2, 3. Okay. So A contains the list 1, 2, 3. And let's also set, let's call it like C, I guess, and then we'll make a con cell C, and that con cell will have 1 and 2. So that's what it looks like. That's how Lisp represents this cell. So let's use the car and CDR command. So if I say car of C, that will pull the first element of the con cell. So there's 1. If I say CDR C, it'll pull the second element. So that's 2, so from up here. Now, you should remember, lists are made up of con cells. So what happens if I say car A? You get 1. Okay, it pulled out the first element. Now, if I say CDR A, though, you'll get a list 2 and 3. So remember, this is back from the structure. If I say, so I get the car A is getting the first element of the list, or of the con cell. CDR is getting the second element of the con cell, which in the case of a list is actually a whole other list. It's all the way from 2 all the way down to 0. So that's why we're getting over here, we're getting the list 2, 3. Does that sort of make sense? Okay, we'll keep going.
What you're saying makes sense. I'm just having trouble opening the window. I keep writing VLide and it's gone, but it's okay. I can.
You can also try VLisp. That should also pull up the same thing. Also, when you first open it up, if you have Visual Studio installed, it might prompt you to choose which one you want to be using. It did that to me. So just if you've clicked the wrong one, or if that window's hiding somewhere, just be careful with that. Yeah. Are you using AutoCAD normal desktop, not AutoCAD LT or whatever?
Yes.
Okay. Okay. It's included in all the versions. I think even LT actually. So yeah, it should be there.
Okay. I'll look. Thank you. But you can keep going. What you wrote made sense.
Okay. Okay. So car A, CDR A. CDR A gets the second everything after the 1. Now, I find this really cool. What you can write actually is DDR A, and this will give us 3. So the first D got the second element of the first con cell in the list, and the second D gets the second element of the second con cell in the list. And so you can actually take that a step further. You can say CADDR A, and that will give us 3. And so what that means, this first D is the second element of the first con cell in the list. The second D is the second element of the second con cell in the list, and then the first element of the last con cell in the list. So if we take a look back at here, you can see, so it's saying, so the CADDR, so D is looking at that cell, and then the second D is looking at that part, and then the last, the A is looking at this first part, and that value is 3. So that's the whole thought process there. And you can actually combine these in any number of ways. So you could do CDAR. These might not actually give us a value. Yeah, it'll throw us an error, but if you had a properly formed list, you can traverse it. You can work through the list just combining D and A between C and R in arbitrary combinations, possibly up to a depth of 10, if I remember correctly. I think you can have 10 Ds or As in a row. It's kind of fun. So you can do, if we wanted, okay, car A will give us the 1, CADDRA will give us the 3, but CDRA just gave us 2, 3. So what if we wanted the 2? Well, we need to go CDRA, and then we need to go into the first con cell, so that's A, and then that will give us the 2. Fine. Okay. Luckily, Lisp has a way to avoid all of this, and that's the nth command. You can say nth 1 A, and that will give us 2. So that just goes into the list and pulls the nth index. Just like most programming languages, Lisp indexes from 0. So nth 0a will give us 1, nth 1a is 2, like you saw, and nth 2a will be 3, and nth 3a is nil, is nothing. Okay, if we have a list, so there's another command that I'll introduce now that won't seem important now, but will be really helpful once we start talking about AutoCAD. And so let's set A, I guess, and let's construct a list with nested column cells. So we have a list, and then we'll have a cell of 1 and 2, we'll have a cell of 23 and 4, and we'll have a cell of 19 and 0. Okay. So that list looks like this. You can see beginning and end of the list, and there's 3 con cells within the list. The actual underlying structure of that list would look a little confusing, so we won't go into it, but there, you got a little list. Now, we can use the assoc command, or I'm sure it stands for something like associate. And if I say assoc 1a, that will pull out the list, the con cell rather, in the list where the first element, where the first item in the con cell is 1. If I say assoc 19a, that will pull out this cell. This is going to be very, very useful in a second when we're looking at AutoCAD, but we'll just keep that in mind for a second. Okay, so I've already shown you how to open up this window, but let's look at interacting with AutoCAD a little bit. So I'm going to draw a couple lines here. So just L, draw a line. There's one line. I'm going to draw another line down here. Okay. So I've got a couple little lines. What am I going to do with these? Well, let's get some information about them. Okay, so these are these objects in AutoCAD have a whole bunch of hidden properties that you can't quite see. So we're going to want to get those properties. And the way we're going to do that, we're going to start by using, we have to select them. And so we select them and they get turned into a selection set. So the command for that is ssget, so selection set get. If I press that, it'll actually pop me out into the AutoCAD window and prompt me to select a couple objects. So I'll select those just like normal in AutoCAD, and then I'll press return, and it'll take me back to the Lisp window. And here we go. It output a selection set and assigned it a random ID, in this case, 63. Now I haven't assigned that to a variable, so we can't use it. So let's try that again. So we're going to set a selection set. I'm going to call it SS, and then SS get. And now it's going to pop me out here. I'm going to select both of those, and press return, and there we go. And so now the variable SS has this selection set. So now we've got a couple objects in this selection set. So let's access those. We're going to want to find the name of one of these objects. So I'm going to use the command ssname, and then the selection set I'm using, which is SS, and then the index of the object I want to look at. So in this case, I'm going to look at the first object, so I'll use 0. And what does that give us? Well, that gives us the name of the entity. We can't tell which of these lines that is right now. It's not like you can look up the entity name in the properties panel or anything. It doesn't show that up here. But this is the name that AutoCAD uses to refer to this line. If I do, so if you highlight that and press return, that'll actually enter that command down here, which is kind of handy. If I change the 0 into a 1, this will be the second entity on the drawing in the selection set, and that's this name, 27A, etc. Great. Okay, so now for the key. We want to take this name and actually get the properties of that entity. So we're going to use the command entget, so entity get, and it'll output the properties. And we're going to use SS name of the selection set, and we're going to use the first object. And there we go. Now we get all those hidden properties in AutoCAD. So this is the way that AutoCAD stores objects. It has to do with the database that AutoCAD uses to keep track of objects inside drawings. These are called Dxf codes. and you can actually look up the documentation. There's a huge, huge list of them, and they all refer to something a little bit different. So you can see here, -1 is the entity name. And so the Dxf code -1 means the entity name. Whereas over here, the Dxf code 410 refers to the space it's in. So right now, this line is in the model space. But if I went to a layout, it would tell me the name of the layout, or it would tell me paper space or whatever. Over here, 8 is the layer it's on. So you can see this line is on layer 0, which the name, layer 0. And I'm going to actually create a layer for later. I'm going to call it red, and I'm going to name it red. Beeping at me. And then over here, you can see code 10 has the coordinates of the beginning of the line, and code 11 has the coordinates of the end of the line, which is kind of neat. So if I look over here, okay, so it's 15.5, 8.6, and 0. So 0 is the height. AutoCAD is always working in 3D, even if your drawing is only working in 2D. But so, okay, the beginning of the line is at 16.5, 8.6. So let's see, if we go over here and select a line, can we see that over here? 18.6, oh, is it, maybe it's this one? 16.5, 8.6, there we go. Okay, so this is the first object in the selection set. We can see the coordinates over on the side here, are referring to here, and we can match those back up with the beginning of the line over here. So that's the start X and start Y. Neat. Okay, so it's actually, you can get input in a couple other ways if you're working with AutoCAD. There's nope, let me pull this window back over here. There's a get dist command, which will prompt the user to enter 2 points and give you the distance between those points. There's also a get point command, and it'll just get a set of coordinates, which is kind of handy. Okay. So that's a little bit of AutoCAD. We're going to come back to that in a second. Are there questions yet? Okay. Okay. We are, oh, all in the chat. Good so far. Great. Okay. So let's go back to Lisp for a second and talk about functions. So I'm going to create a new script. So you can actually, should mention before we move on, you can enter Lisp code here. You can also enter Lisp code directly from the command line, which is fantastic. So I could do the, if I wanted to know, okay, I just want to know what some of the properties of this line, for example, and I don't want to go through the hassle of going through the console or anything, or this console or something. I can just enter it directly into the AutoCAD command line. So I can do ent get and then ss name, ss get 0. So I'm combining all the commands that we've used so far. So I'm getting the properties of the entity with the name of with the name from the first element of this selection set. Let me just make sure I close all of those parentheses. Blammo, just shows up there. You can also do some less exciting things like set q x5. That'll show up here in the command line. Or if I do set q x is 23, just to demonstrate that actually this is the same environment as over here. If I go over here and type x, you can see it has the value of 23. You might remember it used to have the value of 5 back up here. But if I say set q x as 14, well, we can't just enter x over here, but if I, how will I do this? I think, is this gonna work? Yeah, there you go. So that's to print x to the console is print, and then that's 14, and then it returns the value of 14, so I printed it twice. It's a little funky, but there. See, it's the same environment. Pretty cool. You can also write Lisp in scripts. So as a bit of a hint of what you can do, I've written this before. So I've created this function called fractal, and I've actually created a command called fractal, so that if I come here, let's get rid of those, and I can type custom auto, I have to remember to load that first, we'll get to that. I can type a custom AutoCAD command that I've created called fractal, and blammo, it's created a cool little design. It made a little circle, and that's just all the math is over here, and you can do that. You know, This isn't a particularly useful drawing, but you can do stuff like that with Lisp, and I think that's pretty neat. Okay, so let's talk about how to do that. To write a function in Lisp, it's defun, so like define function, and then the name of the function, so we'll call it function, maybe. Oh, no, that's a keyword. Fun stands for function. Then you have the arguments to the function beginning, so for example, x and y. Then you can have a slash, and then you can have, so for all the programmers, you can define your local variables after that. I'm pretty sure all variables are by default global. I think, yes, I think all variables by default are global. So if you want to make sure that your variables won't get modified by other functions, if they're the same name, you can list them out here. So local A and local B or whatever, and that goes after that. Close off that parentheses, and then let's close off the function parentheses, and then everything we want to write goes in here. If we want to write a custom AutoCAD command, that's actually really, really easy. All we have to do is just say C:, and that will turn into a custom command. You can't give arguments through the command line. Well, it's complicated giving arguments through the command line, so you don't want to do that with custom command. But if I do this, and now I will press this little button up here, which loads that into the active window and into the active drawing, it means we can actually use it. So this function doesn't actually do anything, but if I go over here and type fun, did it say? Maybe I have to make it do something. Set q x5 and then print x there. Okay, it'll just print it to the command line. There we go. Now it says one form this loaded from the editor. The title of our current script is just Untitled 0. Fine. Now I can go over here. Fun. There. We've created a fun command. And blammo. Prints 5. And then just like if you've used MATLAB before, MATLAB does this too. It'll output the last thing that you had on the value of the last variable. And so that's what it's doing there. That's why it's printing twice. Okay. So fine. Define a function with defun and arguments go in parentheses. It looks pretty normal, just like any other programming language, but you can add the C: to make it a custom AutoCAD command. Okay, now let's talk about AutoCAD again. You can do some really neat things from the console. You can run anything that you'd be able to run through here. You can run through the Lisp console. So you can do that by using command. And if you say command, and then let's do line, and we're going to make it go from the origin. So here's the beginning point, and then we're going to make it go to, I think 10 will show up. Let's do 100 just to make sure it actually shows up. 100, and then at Z of 0, and then empty parentheses is just normal return. Close that, and there we go. This line wasn't here before, going from 0, 0, 0 to 100, 100, 0, and we do that through the command line. So any other command, so like circle, or anything that shows up here, any of this stuff, you can do that all just by using this command. Something to note is when you're using this, it can get a little, I think the proper terminology would be janky. It can get janky really fast because when you're using commands like this, it'll respect your settings. So things like your snap settings, like your orthography settings or your object snap settings, AutoCAD will respect those. And for example, if you're selecting things or drawing something between two points, sometimes it'll pretend like you're actually using the cursor and it'll snap it to some other parts of your drawing, which can interfere with what you're doing. So you can use the command set var to set your system variables. And then, for example, osnap is the object snap settings. And then you can set that to 0 to turn that completely off. For osnap specifically, doesn't really matter for the purposes of this tutorial. For OSNAP specifically, though, it is it's like, you do it in binary. It's like an 8-bit long number or something, and then so each bit stands for a different snap on this list, and then you translate that into decimal, enter that into the setvar command, and then that'll set your settings to whatever you want it to be. And in fact, I can actually show you getvar and then OSNAP, and ooh, am I doing that wrong? I didn't prep this part. I don't remember the command. Anyway, no, it's on, isn't it? Anyway, object snap settings. Anyway, use setvar. Okay, so what can we actually do with those object properties that we were talking about before? I want to move, let's move a set of these. Let's move one of these from the 0 layer to the red layer. Okay, so we're gonna come over here, and the first thing we're gonna need is to get the list of properties. So we're gonna do that ent get, ss name, ss get. Ss get can actually take some arguments. It's a huge list of arguments, and it can get very, very specific. But a useful one to use is just :S, which means single selection, and so it'll only grab one object. Okay, so we already have an object selected here, so it'll grab that. And then for SS name, the argument's gonna be 0, so we get the first object that we selected, and we're gonna get the properties of that, and let's actually assign that to a variable. We'll call it properties. There we go. Okay, so now prop is that list of things, and it's the line going from well, here to here. Cool. Okay. So if you take a look at this, like I might have mentioned before, this is a list made up of con cells. And all we have to do to edit an object is just swap out that con cell and then tell AutoCAD to update itself and update its database to update the drawing. Okay, so if you want to figure out what this is where the ASOC command actually comes in handy. So if you're wondering, okay, I've got some entity. So I've got some entity. I want to know what layer it's on. I can use ASOC, and then the code is 8, and then I can take the properties list, and there it'll give me the con cell with the layer 0, because the code for layer is 8. I don't know where they get these numbers. It seems fairly random. I'm sure it's based on historical precedent, like everything. Okay, but what if we wanted to swap them out and edit the object? Okay, so we start with the command subst, which substitutes a con cell which substitutes an item from a list. Okay, so we're going to substitute, okay, I have to remember, I think it's the new value first. So we're going to create a new cell with the new data we want in there. So that's going to be, instead of 8.0, we want 8.red to put it on the red layer. And then the old cell we want to swap out. So that's going to be whatever layer it's currently on, which is how we just fetched it up there. And then the object we're swapping, the properties list of the object we're swapping. Yes, the property list of the object we're swapping there. And then it'll, yes. Okay, so that outputs a new list. And if we've done it correctly, yes, there we go. Okay, so now if I type prop, oh, I didn't assign it. Okay, well, this command outputs this new list, which you can see has red, whereas prop still has 0 on the layer. Okay, so now if I pipe that into the command entmod, and then I can copy and paste this whole thing down there, this is going to take whatever list of properties we give it, which in this case is the modified list of properties, and it will update the AutoCAD drawing database for specifically whatever entity name is indicated by this list. So if I press return, we pop back over here. Ah, fantastic. This object has been moved to a new layer. This object is now on the red layer. It's changed color. Okay, so all we had to do for that is use the entmod command and substitute a new entry. So if you want to put it back into the old entry for some object. Let me close everything, and there we go. It's back on its original layer. Okay, that's a little bit of a hassle just to do for one object when you could, come in here, click it, and just use the drop down there. But you can automate it. You can do it if you had to do it for thousands of lines for hundreds of different layers. This is very handy. Okay. So you can combine all those commands up here in a little script like this, just like I showed you. And then you load them into the active window with this. The last little bit that I'll just tell you about and describe, and I'll actually come back to the slide deck for this, is just the fact that you can actually get programs to load automatically. By default, nothing, you'll have to open up your file. So in this case, my fractal file that I wrote, I'd have to open that up every time and press the load button and whatever. But you can use the acad.lisp or .lsp or acaddoc.lsp. You can create the file. There's a brief set of instructions here. I do recommend Googling it if you really want to do it, but there's a brief set of instructions here in the slide deck to do that. But you can edit these files to actually have scripts load automatically every time you run AutoCAD. ACAD will load every time you run AutoCAD, whereas ACADdoc will actually load only, it will run every time you open a new drawing. So if you, for example, for whatever reason you wanted to insert a title block every time you create a new drawing automatically into the layout or whatever, you can do that just by editing this acaddoc.lsp. Okay. That's the summary. There's a whole bunch of useful links here. I have a minor activity planned, but I'm going to stop the recording for that, and we can just figure it out. And the idea is that I can provide you some feedback and maybe get up and running pretty quickly. But before I stop the recording, are there any questions that might be helpful for the folks watching later? Questions, concerns? Compliments on my fantastic little fractal drawing thing? No? Okay.
It's a circle now. Last time we saw it, it was just the one fractal.
Yeah, well, that was easy.
Very nice.
I just added an extra loop and multiplied the angle a little bit and just rotated it around. Programming. Okay. Okay, I'm going to stop the recording then. And here we go. Stop recording.